Let's get started. So today I'm going to be talking through the notebook that I published earlier this week where we looked at the clothing reviews data set. But we've also got Ken Gu on the line with us. He's the author of the Multimodal-Toolkit, which is kind of been using as our reference for all this stuff. So thanks for joining us, Ken. Really appreciate it. Looking forward to kind of picking your brain on some of this stuff.
Happy to be here.
Yeah. So let me go through some of the results from that notebook in case you guys haven't looked through it yet. So as kind of like a reminder, that the clothing reviews data set, it's got a text feature in the form of the review, but then it's also got these like numerical features like what the user rated the clothing item and their age. And then it's also got some categories for each one. So these numerical and categorical features are pretty valuable for this data set. So we want to be able to combine the text with those other features. And in this notebook, the main strategy I took for doing that was to basically convert everything to text and feed it through BERT. But first I tried some kind of baseline strategies, so I'll share the results on those real quick. So the data set's like, it's really imbalanced. So 85%, something like that, of the reviews recommend the product. So if your classifier just always recommends, then you get an F1 score of 0.906. So that's a good, like we need to do at least better than that. That's our kind of bottom. And then we saw from another notebook that we looked at last time that the rating is a really strong feature. So if you just kind of threshold on the rating and basically recommend the product if the user gave it a rating of 3 or greater, then you get a pretty high F1 score of 0.953. And then when you've got this like mix of numerical and categorical features, kind of the norm is to apply a decision tree. So XGBoost is used a ton in Kaggle competitions. So I tried this out. A little more complicated, but not too much. So there's like a couple pre-processing steps. The categories need to be turned into integers instead of strings. So the way I did that, I found like, Googled around, found different approaches for doing that. I landed on this one. Pandas has this like category type. So you can basically recast the categorical columns as this category type. And then once it's a category, there's this like codes property that gives you the integer that it assigned to each category. So once that's done, the division name, department name, class name, they all have these integers now instead of strings. And then, something I haven't, this is my first time using XGBoost actually, so I'm not familiar, don't have a ton of experience with it. So one of the things that, one of the things that's important is like it needs to distinguish between numerical features versus categorical ones. Excuse me. So I don't know if this is like the official way to do this, but it worked. So I took the numerical features, the age, rating, and positive feedback count. That's like the number of people that like upvoted the review. So I cast those as floats, and that seemed to be enough to kind of convey to XGBoost like those are numerical features, and then the integers are categorical, so it can treat those differently. And yeah, so then training's really easy with the XGBoost module. It looks like it's designed to match scikit-learn, and that gives us an F1 score of 0.965. So that's cool because it does outperform just looking at the rating. So it tells us like some of the other features are important, but and then XGBoost does like, you can look at the model to try to figure out like which features it finds most important there's this plot importance function from the XGBoost library. So it shows this kind of ranking. I don't know how to interpret that entirely because I did see another article on Medium that said like they looked at like the different ways of analyzing feature importance in a decision tree, and they said that this gain attribute is really the best thing to look at. So if you plot just the gain for the features, then it gives this really heavy weight to rating, and a lot less to the others. So that sort of matches our understanding, at least, of like the fact that the rating is a really strong feature. But yeah, I don't know. See, do these kind of line up? Yeah, they kind of line up. So that's good. Like rating, clothing ID, age, positive feedback count. Yeah, probably makes sense too that what department or what kind of clothing item it is seems like it wouldn't tell you that much about what the reviewer is gonna say about it. So I think it seems fairly logical. Yeah. So and then finally, BERT. Just combine everything into strings. So I go through the data set row by row, and I took the route of, instead of just like appending the strings, I tried to give BERT some context so that it could like interpret. My intent was that give it some context so it could interpret the feature better. So I actually like wrote this, fabricated sentence where they say like, this item comes from the blank department and blank division and is classified under blank. And then, insert those features in there. And then I am, 30 years old or whatever the age is. And I rate this item 3 out of 5 stars. So otherwise this would just be like the number 33 and then, I don't know, a space and the number 3, so I think I'm assuming it helps BERT to know like what these features are, if you can kind of use some natural language to explain it. I didn't try the other way. So I guess, Ken, this would be a good question for you. Do you remember, like, for the unimodal approach, did you do something like this, or was it more just, was it a little more straightforward?
I think it was just the raw text, but between each feature, it would be separated by a sep token.
Oh, okay.
Yeah. Interesting.
I'm going to write that down. Let's see. Yeah, so for unimodal, just kind of, what you referred to as this kind of everything to text method. Features were converted straight to text, but separated by an SEP token. All right. Well, that's cool, because I did notice, like, let's look at the results I got, because I think the results I got were very similar to yours. So if that worked, then that's much less wordy than what I put together here, much fewer tokens. So that's good to know. So then I appended the title if it had one, and then the review text. So then you get, so here's an example. This item comes from these departments. I'm this age. I rate this 5 out of 5 stars. And then there's the review text added on here.
Oh, I just want to mention what you're doing is actually kind of like prompt tuning almost. Right?
Yeah.
You're adding, so it's pretty interesting stuff.
Right, like kind of, giving it some indication of what you want it to do with the data. Yeah. So after that, it's just the normal like classification with BERT, since all you've got is a big string at that point. That got 968. And then I did also just kind of like as another baseline, sent just the review text through BERT to see what it could do with that. So that was not as good. Not as good as like the rating seems to be a stronger feature than the review text. But at the same time, the review text is strong enough that BERT was able to do pretty well with just that text alone. So I think it kind of reaffirms like, yeah, it's ideal to have both.
Hey, Chris, just a question on that. You know, I think in your BERT model, you decided to go with cased rather than, you decided to go with uncased rather than cased. Was there a reason for that? And the reason I'm asking is because, especially with reviews, you'd think that something like, you know, if someone says, I thought it was great, and they put in big capital G, big capital letters, there's more of a, you know, there's a bit more meaning there as opposed to it being in smaller, and so that's like both for sentiment analysis and something like reviews. But I haven't tried your thing with BERT cased to be able to determine if it provides better results. But I was just wondering if there was a rationale behind your thinking.
There was not a rationale. So I like your insight there. I think, yeah, that'd be interesting to try. And it sounded like you were suggesting that that's maybe like a good good rule of thumb maybe for sentiment analysis, that the cased model is a good idea.
Yeah, I mean, I've seen it work in a sentiment scenario. This is quite similar because it's a review, but I think we'll probably need to test them both out and see whether it actually makes a difference.
Yeah, cool. Yeah, that'd be interesting to try. It's a good thought. Yeah, I definitely just, I don't know how I ended up with uncased, but I didn't think about it. So, all right, let's see. Is there anything else to share in here? Yeah, so this is the same score that Ken, you guys reported in your table. So the additional text that I added didn't add any. It didn't push us any higher than your technique of using the SEP token. So that's a good insight I should add.
Hey, Chris.
Hey, Vijay. Oh, we lose you? Let's see, what was I going to write here? I was going to say, oh yeah.
Could you talk a little bit about this Unimodal? Because I'm not sure what the link is between Unimodal and what you've just done.
So yeah, so modal or modalities kind of refers to different types of features. So text is one, and numerical is another, and categorical is another. So here we're just using a single modality. We're just using text. However, we're not just using the text features. We're converting everything to text. So we're converting everything to one modality. Would you say anything else about that, Ken? Is that a pretty good summary? And is that a term, I guess, that you've seen elsewhere, or something that you adopted because it made sense? Or
I think I just adopted it because it made sense. But yeah, what you said is like exactly how I described it.
Cool. Okay.
Mm-hmm. Or actually, I think I kind of forgot, but maybe I saw it from some like more traditional like vision text paper where like one modality was called Unimodal. I don't remember exactly though, but yeah.
Cool. Yeah. Yeah, it's it was kind of crazy that like there wasn't. I mean, maybe it didn't search hard enough, but it didn't seem like there was much out there on like dealing with numerical and categorical features. Like it seems like there's a lot going on recently with like combining vision and text. And that was like what your blog post explored.
Right.
But I think your toolkit was sort of the best resource we found on this problem, which seems like it ought to be the more common one. It seems
that was like the complete motivation for writing it in the first place.
Yeah, that's cool.
Hey, Chris. I wanted to make one comment. So the extra text that you added, maybe because it was added across all the samples, that was the reason it did not add anything to the accuracy. Could that be the reason?
Let's see. Yeah, tell me more of what you're thinking there. What having it in all of the samples makes it less unique, but
yes.
Yeah. I mean, the intent was to kind of like help BERT understand what it was. So my thought was that like, instead of just the number 33, if BERT knew that that number referred to the reviewer's age, would that somehow tell BERT, what to do with that feature, how to take it into account. But yeah, maybe thinking through that out loud, I could see how it's like, well, no, it's just BERT figures out how much attention to give to that feature in the classification decision, like regardless of what it is, right? It doesn't need to know necessarily what the feature is to figure out like how much weight the embedding for that feature should be given in the classification decision. So yeah. So I feel like I could see how it's not necessary really to define the features for BERT. So I have a comment there. Cool. All right. So the other thing I wanted to go through today, I've started moving on. So there's 3 data sets that Ken, you guys ran on in the toolkit. So the first was that clothing review one, and then the next one is like a pricing prediction one on an Airbnb data set, and this one seems interesting because the unimodal approach did not do as well in your experiments, and then here this is a regression problem. So the mean, what's the A? Mean average error or something? Mean and average are the same. Anyway, we want the score to go down. We want to minimize the error here. So the concatenation approach looks like it worked best by this metric. So, and that's a relatively simple one to understand. So I thought I'd try that one next. I've done some of the coding for that, so I'll talk about that a bit. The data set's fairly interesting to look at, though. Let's see. Do I have it open? Airbnb data set. There we go. So it actually has 275 columns in it. And if you look at them, there's like some we obviously don't need, like the listing URL. I imagine that doesn't. Oh yeah, and the objective with this data set is to predict the cost, the rental cost. Like I think it's like rental cost per night. So yeah, so it's got some text features, the name, summary, description of the space, description. Do you know what the difference is between like some of these features?
I think the description is just like a longer version that the user provides of the listing. I think I've not, as a user, I think maybe the host provides both of those, but one's just shorter so people can like look through it faster.
Gotcha. Okay.
That's my understanding. Yeah.
Yeah. Let's see. So yeah, neighborhood overview, some notes. Man, yeah. So a lot of text features actually. And then, right, some more URLs that I'm guessing aren't useful. Right, host location.
Well, for this problem, you can even have a model that handles the image modality too.
Yeah,
So, yeah,
that's a good one. That would be cool. Assuming those images are still up.
True.
What's thumbnails, neighborhood? Is the address in here? Street, yeah. Street, oh, neighborhood. Neighborhood seems like a good feature. I was going to say, like, if there's an address in here, then like converting that to longitude and latitude or something, like giving the model some way of like comparing the locations of these things seems like it would help. But it looks like there's a fair amount of information here to do that, like the zip code, the neighborhood. So that's cool. And then tons of these, like, does the listing have a heated towel rack or a standalone steam shower? So there's a lot. Let's see, did it cut off any? I feel like that's not 275, but and then I did notice, Ken, in the configuration for this data set that it looked like you had selected maybe about 100 of these features. Did you kind of go through and like pick the ones that you thought were most informative, or how'd you narrow that list?
I just picked the ones that intuitively felt might help. And then any of the features that were like pretty clear they were like not going to be useful, like a link, for example, that would be discarded. And then yeah, so you know how they had like features for whether there's a bed or not, or all of those? I think those are turned to like binary features.
Yeah, okay. To kind of reduce the, let's see, what would you do with a binary feature? Would you kind of like concatenate them all into a single?
Well, it would be like I think just 0 or 1 for that feature. Like it said in the raw data, it's like true or false for whether they have some amenity, right? I think it was either 0 or 1 for that too.
Does that?
So I think it was
does that mean like, is that 0 or 1 stored as a float, or?
Yeah, like a float, which would be, I forgot whether it was in categorical or numerical, but I think it's like a categorical feature, but it's like label encoding instead of like one hot encoding.
Label encoding versus one hot encoding, yeah. Right, okay. So one hot encoding would be more if there's a bunch of different categories?
Right.
Okay. Yeah, where did I run into that? Right. So, I started out. So for implementing the concatenate approach, what I did is I took your classes. I think I've got them here. So you have like BERT with tabular is like the main class, and then there's a separate one that handles the feature combining, and there's some like utility functions and a specialized config object. So for the for the purposes of like explaining techniques and demonstrating them, I try to like avoid classes and functions as much as possible. Try to make it like really flat and yeah. So what I did is I kind of like took out the relevant code for concatenating and condensed it all into one class. So much less configurable than the toolkit, and only does one method, but I think it makes it a little more clear just to see how concatenation works. Let's see, was I going somewhere with that? I know I did want to ask about the encoding. I noticed, let's see, right, feature normalization. So yeah, so something like I haven't had to deal with in a long time since I've been like doing tons of stuff with text. We've got numerical features. They can all have different ranges,
Right.
which is kind of bad for a multi-layer perceptron. So did you do some like pre-processing of the features to normalize them? Is that part of the
Right,
problem?
and it is part of the process, and like one of the data loading like functions that is part of the toolkit, kind of like you can choose which like sklearn pre-processing method to use. So it like definitely normalizing your numerical features would help with performance, from my experience.
Cool. Can you capture that real quick? Yeah, so that's in, and you said that's in the, is that in this load data function? I think maybe is where I saw that. Training. Yeah, there we go. So different encoding types, numerical transformer method.
So that's like the normalization.
Nice. Okay.
Yeah.
Yeah, I did manage to, so I applied it to the clothing reviews data set. And when I used, so one of the things that's different is I use a MLP on the end as a classifier, which I think makes sense because with BERT, like you've got a single layer classifier because you have this whole BERT model that can like do all these complicated things in order to encode whatever it needs into the CLS embedding. And then, yeah, so then the classifier doesn't need to be that sophisticated. But when we're combining other features in, a more powerful classifier, I think, makes sense because it can do more to, like MLPs are able to learn some feature extraction, so they can like apply some transformations to the numerical and categorical features. So that seemed to help a lot with the score. Let's see. Yeah, I'm sort of out of order here, sorry, but so the concatenate method is like you just sort of assemble all the features into one vector. The text feature is the CLS embedding that comes out of BERT, so that has 768 values in it, and then clothing review data set has, I want to say, like 3 numerical features and 4 categorical ones, so you end up with like a vector that has 775 features in it, and that's where you feed into the MLP. Nice. Yeah, I think that's what I had on there. I did see like there's batch normalization, which I think I've learned what that is at some point, but I've forgotten. Does that do something different than the kind of like pre-processing feature normalization?
I think batch normalization in like the term is actually more used like when you're between each layer of your network. It's kind of to stabilize your like your features as they pass through the network. Because if like at one point it's like super large, like you can get exploding gradients. Or if it's too small, you can get vanishing gradients. I think that's why it's used, and it helps with training. Basically, helps you converge to like the minimum.
Yeah. So right. So I've got a lot of the code in place for that, but not polished, not ready to present. And yeah, I applied it to the clothing reviews data set since I already had like the code for kind of preparing that. But I think it's the Airbnb data set where this method will be more interesting. So I think my next step is to parse the Airbnb data set in the same way you did, Ken, and then feed it through this model. So I think that's everything I wanted to present. I did want to see, Ken, what you thought about like the where are the benchmarks here? Yeah, so the so I like doing the unimodal approach because I feel like that's sort of like the first thing that makes sense to try. Is like it's the easiest, right? It's just like convert everything to text and then you just feed it through BERT. You don't have to do anything special. But then for models where the other feature, let's see, or no. Right. So what we've been theorizing, and I don't know if you'd agree with this or not, is that when the numerical features are important, our thinking was that BERT maybe isn't as good at making sense of numbers and the relative quantities. So maybe, if it's like an integer and it's a category, maybe you can handle that. But if you've got like, especially like floating point numbers or numbers where like the difference in value is really important, then our thinking is that like BERT probably can't interpret that very well or like do the necessary math on those numbers to understand, that 300 is 150 more than 150 versus 350 is 200 more. So our guess was that like a different approach worked better for pricing prediction because the numerical features are more important in this case. Do you have any?
Yeah, I completely agree. In the clothing review data set, the semantics of the review probably gives like a super strong indicator of whether it's recommended or not. Whereas for like say pricing prediction, you have a lot of features such as telling you how many beds there are in the home, like the neighborhood and stuff like that can really help you tell the value of the home in addition to the description, right? But then with unimodal, like it has like the limitation of you're kind of limited by the input of the number of tokens you can input to BERT or for any of these language models, right? And then in terms of like learning between the like numerical features or those floating points, from practical experience, like XGBoost is a super strong baseline, and in like our internal work at Georgian, we did some like BERT embeddings, like in addition to like the categorical numerical features as input to an XGBoost model, and that was also a very strong baseline, but it was kind of out of the scope for this toolkit, which is why it wasn't like included.
That's good to know. You take like the CLS embedding, I'm guessing, and feed
Right,
that.
right. But like in all these cases, there's so like our approach or our use case for this was slightly different than what we have here. But yeah, in my experience with all these different data sets, it's like it's really up to the like it depends data set to data set. I mean, it's good to have some intuition of the data set to kind of guide you into what to try.
Yeah, say that last part again. Like what helps guide you?
Oh, like intuition about the data set, for example. Like we have some intuition about the clothing data set, and like what I mentioned earlier, the pricing prediction. You have all these like informative tabular features that you want to include. If you look at the tabular features for clothing review, you can kind of say it might not be that useful for that task of other than the rating, I guess, but like the sentiment in the review text is like already super strong.
Yeah.
Yeah, that's interesting. When we were starting this, we were sort of thinking, well, like, I see, 4 or 5 ways by which to combine the inputs and just kind of structure the model. Mm-hmm. And basically how generalizable will whatever we create be? Because, is it really just going to come down to each data set's different and you have to eyeball it, and then maybe you have a suite of different things to try and you run them through? So I'm kind of wondering, like, did you guys have ideas about if you were going to extend this library, like what are, would you just keep adding kind of different, like architecture techniques or like new Hugging Face models, or do you have some idea about like how to make it kind of more extensible and generalizable?
I think, so both of those are very valid, like including more like transformer models is like one direction. Also, like the way we're combining the features could be different than just like post transformer, like the output of taking the output of the transformer embedding and then doing post kind of processing after that. It could be kind of in the middle.
Yeah.
Right. So that's like kind of extensions that you can do to make it more, to like at least improve on the toolkit. In terms of like one method that like does the best, I think it's not clear what method could be the best. I think a lot of my experience in practical machine learning, it is a lot of like trying what works and what doesn't, right? It's like even the most like well-reported models in academic papers sometimes might not be the best for your use case.
Yeah, we've definitely found that a few times as well.
Right. But BERT, like transformer models, I must say is quite impressive in what they can do.
Yeah. Mm-hmm. No, it's yeah, we weren't sure if it was kind of like, well, is that the reason for kind of the lack of support out there for these kind of problems? Is it just that like, someone might build a great architecture for one data set, but it's really only valid for that data set. So like, research teams are like, I can't really publish on this. It's just too like one-off every time.
I also feel the motivation behind like this project is very application focused than like research focused.
Yeah.
So that's like kind of like siphons off the type of people who would work on this.
I mean, did you guys run into a lot of these specific kind of problems?
Yeah.
I'm not totally sure what the work at Georgian was, but was it really this kind of thing over and over?
So let me just give a bit of background. Georgian is like a venture capital firm that invests in a lot of like growth stage AI-based companies. Mm-hmm. And their like whole proposition is they do a lot of applied research. And you can imagine in a lot of Georgian's portfolio companies, they have like real world like machine learning problems they want to solve. So with all these like problems that are presented to Georgian, they like this kind of stuff would be very valuable to like a lot of the portfolio companies, like the problems that we face too. Mm-hmm. Mm-hmm.
That's cool. So it's sort of like in the way that like an incubator kind of helps startups by providing lots of expertise that that you need to like start a business. You guys are helping the portfolio companies with like machine learning specifically.
Right. So the portfolio companies are like, so I'm not super familiar with like VC terms, but they're like Series B or Series C, I think. And at that point, like the whole value proposition of Georgian is the like applied research and like the engineering team, R&D team at Georgian can like help your team and like improve your products basically with this like collective expertise and knowledge.
I see. So it's like an investment of capital and kind of resources and whatever this platform is. Right.
So this like, you can imagine like if Georgian offers like this kind of like expertise, then more companies would want to take their investment because of the value that Georgian as an investor provides.
Mm-hmm.
Mm-hmm.
So one question I had, trying to decide. So I'm gonna do the Airbnb thing and do the concatenation approach. The third data set I haven't looked at yet. It's like pet adoption prediction. I think were you saying earlier before the call that like the text features aren't that strong in this data set? Or am I misremembering?
Right. I think the text features aren't that strong, but also like it's just like a pretty hard task in general.
Yeah, it's like it's not
right. So you're kind of predicting the future in this type of task, right?
Is it?
Sorry.
Are there a lot of labels like? Is it a binary classification problem or
it's a multi-class?
And are there like?
It's like 5.
Is it 5? Okay.
I think it's 5. Yeah.
All right. So not a huge number. Okay.
Mm-hmm.
Sorry for interrupting. You were saying?
So the like the methods here, at least for pet adoption, I remember looking on the leaderboard and they do achieve, I think the evaluation is slightly different, but they, I think, achieve like higher scores. So like these are just to compare between the methods themselves, but there may be for methods that rely heavily on non-text features, there probably are better methods out there to for that task. So it is like application specific in terms of using these methods too.
Yeah, interesting.
Yeah, sort of. This is a pet adoption predict. There's no picture included. I haven't looked at the data set, but it seems like that would be the.
I forgot, but if there is pictures, like we wouldn't include it either because it's like out of the scope of. Kind of
My thought was it's got to be 95% on the picture, but yeah, who knows?
Oh, like how cute the picture is.
Yeah, like
That's true.
Well, I mean.
They do.
There are. Yeah. So in this case, it goes back to this data set has images that might be more useful for the task, right? So you might choose more image-based methods.
Yeah. So I think exploring some of those methods that like combine visual features is something we really want to do. We're kind of thinking of doing that next after we've finished exploring sort of the categorical and numerical feature stuff.
Mm-hmm.
So this approach was like the most complicated, it looked like by far, but it did perform the best on this data set. How interesting do you think this approach is?
I think
do you think it merits?
this approach is kind of adapted from that paper, right? And that paper, their multimodal task is slightly different. It's like aligning video, audio, and aligning video and audio, I believe. So in that case, you can imagine there's some kind of like alignment that you would want to do between the video and the audio. So then their method is kind of like account for that. So they account for like kind of shift between the modalities. So it's not, so in our like categorical and numerical sense, it's not very intuitive in how that applies. But yeah, I kind of include it anyways to just kind of see like one of these like state-of-the-art methods, how they would do in like this kind of setting.
Nice.
Mm-hmm.
Let's see. All right. So yeah, and then it does the best. It performs the best by like a pretty decent margin. Do you have any intuition on like why that's the case? Like what's special about that technique that helped it outperform the others?
I think it's like a more complicated weighting scheme on like how much like attention or importance we pay to each modality. That I think that's the high level intuition I get from that method. So like the last three can kind of are, to me, or at least are kind of variants of each other. Whereas like concat is not as like, concat won't like is more like simple, right? More Nova in that.
Yeah. Yeah, I think this one appealed to me because it seemed like what I might want to try, like trying to interpret it as like, creating embeddings for the categories. Let's see, weighted feature sum. Yeah. So you were explaining earlier that what it does is it ultimately produces a length 768 embedding that represents all of the numerical features, and then another one that represents all of the categorical features, and then the text one, and those are combined.
It might work better when you have more numerical and categorical features, because if you have like 3 numerical features, it's up projecting like a lot, right?
Okay, interesting. Cool.
Hey, so Chris, I've got 2 fairly simple questions on the clothing data set.
Yeah.
I'd like to ask at some point, but whenever you're...
Yeah, no. Go ahead.
Okay, cool. So I guess one of them was, given that the data was skewed, right? Why did we not use MCC as our metric for that? What was the reason why you chose not to go down the MCC route? And then why did you pick F1 as the F1 score as your metric?
That's a very valid question. It looks like, Ken, you did area under the curve, which is another technique for scoring imbalanced data sets.
What is it? So yeah, I think that's a good question too. I like kind of went through this as just kind of finding data sets and finding like models compared to. I didn't spend too much time into like data processing or like specific evaluation metrics. So it's kind of like where my time was placed, where I didn't kind of focus too much on finding like the best metrics.
Yeah.
So what's the reason why you picked F1, the F1 score?
Oh, because I didn't do the data exploration into the class imbalance. To me, it was like a binary classification, so I just felt like one of these binary classification metrics would do enough justice to compare between the methods.
Yeah, I'd say it's a good catch, John.
Mhm.
It's like another thing that, yeah, would be a good modification, it sounds like. Yeah, did you have another question?
The other one was also quite. So when you did your on the clothing data set, when you did your train test split, I was wondering why you didn't split it in a way that was representative of the data. So, something like a stratified kind of split. But maybe you had a good reason for doing that.
No.
So I think you just a random, you split, you shuffled it, and then you just split them into, 80% and then 10 and 10, but not putting them in the sort of order that without taking into account, how much there is of each in the training and validation set. But I don't know whether that would have affected your results. But I don't know whether that was important either.
So yeah, maybe you could educate me a bit there. So you're saying when you've got a data set where the classes are imbalanced, when you're sort of like randomly creating your train and test splits, there are techniques for making sure that you kind of maintain the same balance in each split?
That's right. Yeah.
Okay. So for imbalanced data sets, it's good practice to
Well, I don't know about it being good practice, but I was just wondering whether it.
Yeah, I mean, it sounds right. Yeah. It's good practice to try and maintain the ratio of classes in each split. Yeah, I mean, that makes sense to me because it does seem like, yeah, if you had a test split where it's like, 95% recommended instead of 85, then that could affect things. Yeah.
Yeah,
Are there?
the one for that is stratification, but
Okay. Stratification. Cool. Yeah, I'll look into that. Sounds like a good lesson for me. There's a lot of, like, as I work on this stuff, there's a lot of like really basic machine learning stuff that I keep learning. So that sounds like an example.
Yeah, I mean, supposedly as the data set gets larger and larger, that takes care of itself. But yeah, it's a good thing to look into. It's something I don't think we think about much.
That's a good point. So we got a few minutes left. Ken, would you be up for like sharing a bit about what you're working on next? You were saying like working on prompting. I guess I should let you decide whether you're willing to share or not.
Well, I can kind of talk about the method side of what I'm working on next. So recently, I've been exploring like GPT-3, these generative language models a lot, and in these models, like big idea that's recently come up is like prompt tuning, or just tuning the input to then generate kind of the output you want. Whereas like traditionally, if we want to have like adapt to a task we want to do, we would fine tune our language models, right? In that case, we would kind of update the weights of the entire model, which is a lot more costly. Whereas if you can, say, for example, learn an effective input embedding space for like the prompt, because in the end, the words are just embeddings, right? Then you could achieve good fine-tuning performance with a lot less parameters. So like this idea has been shown to be doing pretty well and kind of efficient in terms of parameter use too.
Are you trying to have this approach on, is it kind of exclusively on GPT-3 or like those?
No, so
models?
so GPT-3 is like closed beta, right? So to actually get the embeddings and stuff, all the papers are kind of choosing their own language models, such as BERT or T5, for example, and then kind of just saying, oh, this can be applied to GPT-3 too. Mm-hmm.
We looked at T5 last week as part of like Nick's been talking about question answering stuff. And he shared this illustration. Is this a good example of prompting where it's like for each input, there's sort of like a task?
Right. So this is kind of like human input telling you like the prompt, right? So then the next extension is like, how can we automatically determine a good prompt for our task? That's kind of the like idea here.
Interesting.
Cool.
Yeah.
Any last minute questions? Nick, it looks like you've been like going nuts in the chat. Anything like anything we should share from there?
I don't think so. Mostly just clarifying kind of the what was going on in the notebook.
Cool.
Yeah.
All right. Well, I think we'll wrap it up there. Ken, it was great to meet you. Thanks so much for joining and lending us your insight. That was great. Really
No worries. I'm happy to be here.
Awesome.
Yeah, thank you.
All right. Well, have a good week, guys. Thanks again. See ya.
All right. Bye, guys.
Thank you.